Hi, so in this video I'm going to be demonstrating how to do 64 game 2. Just starting with the rules and the setup and explaining some of this conditional reasoning that we're going to see here. So a government needs to assign new ambassadors to Venezuela, Yemen, and Zambia. So we'll just represent those similar to how they do in the first question. So these are three groups, it looks like, because we have five potential ambassadors. So the candidates for these ambassadorships are J, K, L, N, and O. So five potential candidates. One ambassador will be assigned to each country. So we have 3 in, and no ambassador will be assigned to more than one country. That means 2 are going to be without any ambassadorship. So that's our out group. Okay. Either K or N, but not both, is assigned to one of the ambassadorships. So K or N, but not both, would mean that if K is in, N is out. If N is out, K is in. If N is in, K is out. If K is out, N is in. So we actually have a biconditional here. Okay. So usually with conditionals, the arrow only goes one way. So usually our sufficient condition is sufficient but not necessary. And our necessary condition is necessary but not sufficient. In this case, both conditions are sufficient and necessary. So that means that we can go back and forth. A or B, but not both is one example of that. There's also A if and only if B. Okay, so these are indicators that we have a relationship where we've got conditions that are not just sufficient or necessary, but both sufficient and necessary. In this case, A and B would always be split up, and in this second hypothetical case, A and B would always be together. Okay. Yeah, so, I mean, this one, you don't have to write it as a conditional. If you just have the understanding that one of these out positions will be occupied by K or N, and then one of the spots in here is going to be occupied by the other one, that also works. Okay. All right, if J is assigned to one of the ambassadorships, then so is K. So this is what we would typically see. If J, then K. If not K, then not J, right? So this leaves open the possibility that K is in and J is out. Whereas this one over here, it's not possible for them both to be out or both to be in. So with this one, both of the consequences could be true, that would be fine. But in this one, we don't have like a trigger and a consequence side necessarily. Yeah, and this is going to connect to the first rule. So if N is in, then we know K is out and J is also out. And if K is in, we also know that N is out. So that's how that would connect. If O is assigned as ambassador to Venezuela, so if O is in Venezuela, that's not a matter of just O being assigned to an ambassadorship, but actually being the ambassador to Venezuela. Then K isn't the ambassador to Yemen, but this doesn't necessarily mean that K is out completely. K just isn't assigned to Yemen, right? If K is assigned to Yemen, then O can't be assigned to Venezuela. And you don't have to write it like this. I'm just doing that so that it looks similar to my diagram above, but that's not necessary. If L is assigned to an ambassadorship, so if L is in, then it is to Zambia. I almost said Namibia. Okay, which I think is a combination of Zambia and Namibia. My bad. All right. So if L is assigned to an ambassadorship, it is to Zambia. So that means L is assigned to Zambia. If L isn't assigned to Zambia, then L is out completely. So what this means is basically just either L is assigned to Zambia or L is out. So L can't be assigned to Yemen or to Venezuela. Either Zambia or out completely. So that should clarify each of the rules. Okay, and if you do need to do a little bit more work on conditional rules for logic games, if you're using the LSAT trainer, then the chapter would be chapter 13 for logic games. Conditional rules and biconditionals are actually mentioned in chapter 14. So is the phrase only if. So those are like clarified a little bit further in chapter 14 if you wanted to just search those that phrase and that word to get a little bit more practice with that stuff. Okay. So I'm going to go on to the questions now. If you needed help specifically with the rules, then it would probably be a good idea to try the questions on your own before coming back to the rest of this video. All right, so for question 7, we are just going to eliminate the rule breakers. We're just going to do process of elimination. So first one, we should see either K or N, but not both of them. So if we see both K and N, like in D, that one's out. And then if we saw neither, then we would have to eliminate that as well, but I don't see that as an option. So we've applied rule 1, found the rule breaker. If J is present, K needs to be present, so A is out. So we found a rule breaker for that. If V has O, which is present in E, then Y can't have K, and it does, so E is out. Okay, so we found the rule breaker for 3. We're between B and C, and the last rule is just that if L is in, it's assigned to Zambia, so L can't be assigned to Venezuela, meaning C is out. Found that rule breaker. The correct answer is B. So what do we have? We've got Venezuela has Cain, Yemen has Aramillo, I would guess, and Landon for Zambia. Okay, KJL, and then the players that are out are N and O. Okay, so that's one acceptable solution that we keep in our sort of abstract bank of acceptable solutions. So when I say keep it in your bank of acceptable solutions, what I mean is, you know, put a check mark next to it, and then that kind of signifies that, oh, this is one solution that's acceptable. Maybe you'll use it later on. Just use that knowledge that this is an acceptable solution. You could use that later on. All right, question 8. The pair of candidates who are not assigned to ambassadorships could be, okay, which pair? So one of the things that I mentioned when it came to this rule was that we have to have one of them in and one of them out. So we should see one of these two players in the in group, exactly one, right? If we saw neither of them, that would actually be a problem. So putting them both out would be a problem, and putting neither of them out would be a problem. So the out group also needs to contain exactly one of that pair. So B is out because it contains neither K nor N. And D is out because it contains both K and N, and E is out because it contains neither. So we can eliminate 3 of the options based on understanding the first rule. And then we've got a little more nuance. So if J is out, that actually doesn't have any consequences. So it's a consequence of the contrapositive here, but the arrow doesn't go both ways, so that's not going to impact K's position. N being out will impact K's position, so K will be in, but there's really nothing wrong with that. So this would be a situation where we have K, sorry, so out J and N. That means that O is in, which, yeah, as long as we don't break rule 3, no problem with that. L is in, therefore L has to be assigned to Zambia, so we know that for sure. And now we have to make sure we don't break this rule when we add O and K. What we can do, though, is we can avoid this rule altogether by just doing both of the consequences and avoiding the triggers. So by putting O with Y and K with V, we've avoided those triggers. We've created an acceptable solution. This is possible. A must be the correct answer. We can double check that by showing that C is impossible. Why is C impossible? Well, if K is out, which is what this represents, right? These are the pair that are not assigned to ambassadorships. So if K is out, J should be out as well, but they have K and L out. So C breaks that rule. Question 9. If O is assigned as ambassador to Venezuela, we don't have an example of that, so we'll create that from scratch. So O is assigned to Venezuela. Well, then we know that K can't be assigned to Y. So if K's in, then K is assigned to Zambia. And if K is assigned to Zambia, then that means that L has to be out. So we can try that scenario. So K assigned to Zambia, L would have to be out, N would also have to be out because K and N can't both be in, and then J would have to be in. So that's definitely an option. So the other 2 ambassadors assigned could be J and K. That's not an option that they give us, right? So we are looking at a situation where K is out altogether. We've already shown that this is the only situation that would work if K is in. So O, we have K out, which means J is also out, which means L is in. L has to be assigned to Zambia, and N would have to be assigned to Yemen. It's the only one left. So this is also an option. Who do we have out? We have K and J out, but we're looking for the other players in besides O, and so N and L, E would be the correct answer there. L and N would be the other ones in. And we have 2 more acceptable solutions for the bank. If K is assigned as ambassador to Yemen, do we have an example of that? No, we don't. All right, starting from scratch. So K is here. That means that O can't be assigned to V, which means that O and L are kind of competing in a way for Zambia now, right? So we can't have both O and L here. So I'm just going to kind of put that there. Basically, one of these guys has to be out. We know N has to be out. So now we know that J has to be in. And if J is in, J has to be assigned to Venezuela. So what must be true? A. J has to be assigned to Venezuela. Okay, and here we kind of have 2 acceptable solutions. So either one of those is possible. Question 11. Question 10. Question 11. Which one of the following cannot be true? This is where the bank might actually come in handy. Can J be assigned to Zambia? We don't have an example of that, so maybe that's our answer here. K assigned to Zambia, we do have an example of that, so we can eliminate B. N to Zambia, don't have an example of that, so we're gonna have to test that one too. L isn't assigned an ambassadorship. We have a couple examples of that. And O isn't assigned an ambassadorship. We have a couple examples of that. So it's just between A and C. So we did actually end up using that bank of acceptable solutions to eliminate things that were possible for this question. So J to Zambia. All right, so that means that K is also assigned somewhere and N is out. We also know that L would have to be out because L can't be assigned to V or Y. If it's in, it's going to be assigned to Zambia, right? So these 2 are out. And then what do we have left over? We have O and K. We would have to put them like this because we can't put O and V and K and Y. That's not allowed, so that would work. So that means A is out, which means C is not possible. Let's figure out why. So, just because we're here, that might be a question that comes up. So why is it that C can't be true? N being assigned to Zambia. All right, so that means K is out. K being out means J is out. Those 2 being out means L would have to be in and O would have to be in, but we run into a problem where if L is in, L is supposed to be in Zambia, but it's already been taken by N, so there's just no way to make this one work. So crossing that out to indicate for the future that that is definitely not an acceptable solution. I'm really running out of room here. Maybe if I just pop that up a little bit. Only got 1 question left. So I'll put it up here. Oh, and we're looking for a substitution. So substitution questions, so this is question 12. All right, so first thing I'm going to do, step 1, is I'm going to treat it just like it's a global must be true question. Okay, so the correct answer would have to be true according to the original rules. And we are, we're looking at this guy here. Now, also, like this one's conditional. I'm guessing that probably we're going to be relating it to the first rule because k is involved in both of the rules. So there's going to be some rule, this is my guess based on experience, that there's going to be some rule that connects the first and the second rule through k. So a rule that involves j and n would stand out to me as a strong contender, because I could sort of sub in what's going on with n to tell me what happens to k. So k and n are related to each other. K is in this rule. I think n can probably be used here as a substitute for k. So for example, if j is in, what would the impact be on n to make k also be in? So if j is in, then n is out, then k would have to be in based on rule 1, right? So we still have rule 1 to play with. If we take this rule away, as long as we have a rule that gets j connected to n, then we could also make it involve k. So hopefully that makes sense, and I didn't like overly confuse that. The only answer choice that does have both j and n in it is D. So I'll test that one first, right? So step 1, does it have to be true according to the original rules? And step 2, would this allow something the original rules didn't? So does it allow more than the original? Okay, so if yes, then eliminate. Does it have to be true according to the original rules? If no, we eliminate. Okay, so D, they're not both assigned to ambassadorships. That does have to be true according to the original rules. We can't have both j and n in, because if j is in, then k is in, and if k is in, then n is out. So it follows the first rule. We're not going to have anything like restricted by this rule that wasn't restricted under the original. Now we have to figure out if this is going to permit or allow things that weren't allowed with the original. So, okay, so with the original, we were allowed to have k without j. So will that be allowed here? So if j is out, then that's not going to have an impact on n, and so it won't have an impact on k. So D would look like this. It would look like if j is in, then n is out. If n is in, then j is out. Okay, that's a not both relationship between conditional. So not both j and n looks like this. That means that it's possible to have n and j both out. So this would still be possible. And so this wouldn't allow, I think I maybe did that backwards. Anyways, this would have the same result, but would it allow more than the original? No, it would definitely restrict. So the original wouldn't allow you to have j without k. So yeah, this wouldn't allow that, because if you have j, then you don't have n, and then you have to have k because of rule 1. So yeah. Yeah, so this one works out. I mean, really, I would have chosen it as soon as I saw that it had j and n, because we're replacing k with n, and they are, like, knowing n's position tells me k's position because it's a biconditional. That's not necessarily going to work in a situation where you have a regular conditional, like unique conditional, one directional conditional rule. But with a biconditional, yeah, K being in, N being out, those things are essentially like you can go back and forth, so they're equal. Yeah. Okay, I'm going to leave it there, but if you do have any follow-up questions, please let me know.